Now let's take a look at something a little more advanced for reporting data or information rather than just using an LED or an RGB LED or even one of the smart LEDs. Let's take a look at LCD screens. Now these are considered character LCD screens, and the reason is the way it displays a character on there is there's a little grid, and that grid can display a character. This one happens to be a 16 by 2. That means it can display 16 characters over 2 lines. I have this already wired up, and the reason I have that is because I wanted to show you to use an LCD screen like this with a backlight. It requires a lot of pins and a lot of wiring, and if you're prototyping and you just need to get something done to prove a concept or test something out or get customer feedback, quite often you want to be able to prototype this a little bit faster, and I have a solution for you. Before we look at that, let's take a look at a few other screens. They come in many different sizes. This is, I believe, about a 12 by 4 or maybe even larger. Here's one without a backlight. So there's lots of different kinds you can get, but what we're going to look at today is this. And this has an included library, and it's a backpack. It's actually a shield that plugs into any Arduino, and it has an LCD screen similar to what you see here. But instead of wiring this to your Arduino, we can plug this into the Arduino. This will handle all of the I2C communications that we need to the screen to display the data. It also has these great little jog buttons here, a select button, contrast potentiometer. There's a lot in this little package right here, and they're not very expensive, and more importantly, it saves a great deal of time. Now that doesn't mean you can't buy one of these for about $10 and hook them up, and you can buy them almost anywhere. The only thing you need to know when you buy these is how they label the pins. On this particular one, let me unplug it. On the back, make sure when buying these, they are labeled. You can see this is pin 1, this is pin 16, and it's ground, VDD, all the way at RSRW, and then all these pins, your backlight pins. I have bought some like this. This is a great example. I've bought some like this, and the pins are not labeled, and they can be a little bit different depending on the manufacturer. So save yourself some time and find one that has a nice silk screen with the actual pins labeled. Now let's look at the backpack. The backpack's really easy. You basically have to download a library, and you can buy these in many different locations. This one happens to be an Adafruit one. And if I go to the product page, you can see there's also a tutorial. Click on single page. I can scroll down. It shows you how to build it. This one does come as a kit. Just basic soldering skills are required to attach all the header pins. And then you download the library, and this will show you right here. There's a GitHub library. I happen to have it right there. You have to install that library. It comes as a zip file, and I'll go over really quick how to do that. You would go to Sketch, Include Library, Add Zip, and you would navigate. Mine happens to be on the desktop. And there it is. I've already installed it for the sake of time. And I've opened up the example. The example can be found in Examples, RGB LCD Shield Library, Hello World. And that's what I have opened right here. And basically this uses a couple of different libraries here. And this just comments out how the I2C connections are. A couple of defines for picking what color the backlight is. There's some debugging. Here's the Hello World. And all of this really is just some sample code. You don't need all of that. That's just gonna print out that we've pressed a button or we've hit select, and we'll take a look at that code right now. And then in the loop, we have all of this, which basically when you read it, you'll see it's very self-explanatory. If I press one of these particular buttons, it will say button up. Now you don't need any of that for running this. You might want to have this button change the backlight color, change a display, scroll through a menu, hit select to change a function. It's a really great shield for prototyping. Now let's take a look at it running on the Arduino. I've got it plugged in. I've got everything checked. I'm going to upload it. It's uploading, and it's done uploading. and it doesn't look like anything happened. This will catch you, especially if you haven't used LCDs before. LCDs typically have a contrast potentiometer, and I'm going to guess that my contrast potentiometer on this one is not set properly. It's the first time I uploaded code to this one. So right here, there's a contrast potentiometer, and as I turn, oh, there it is. So if you go too far, you get all the squares. Typically when it's completely blank, you either wired something wrong, and in this case it's a shield, so I know I didn't wire it wrong, or your potentiometer's set at the wrong amount. So I can turn this and you can see the hello world show up quite nicely. I like it just about there. And if I press the buttons, you can see left, and the code changes the background color. This is just a demo. It's counting every second that it's been played. If I hit select, pretty neat. That's your reset button, hello world. So extremely easy to implement and extremely useful. Think about all the things you can do here. And one thing I'd like to add is, since this is an RGB background on the LCD screen, think about how you can leverage that in your prototype. If I was using this to control a piece of machinery or some kind of equipment, I could have a readout telling me how long it's been running, all different information. But if I made this turn, let's say red, from a really far distance, I'd be able to see something's wrong, and then I could go up to it and read it. Likewise, I could have it green, and then I know from a distance that everything's good. So leverage the color of the background. It's not just for making it pretty. It can be a nice notification for when you aren't close enough to read the screen.